Hello everyone, welcome to MH Math Academy's KCET Crash Course 2025. In the previous lecture, we had revised the chapter sets, and I hope you have read through the chapter and NCRT, and you have also noted down the important points. So in this lecture, what we shall do is we shall take up a few previous year questions, and as I said in the previous lecture, this chapter doesn't carry much weightage for the KCET. So here and there, once in a while, you will get one question in the KCET. So therefore, we have got around 7 questions to solve in this session. So let's see how we can solve this. Okay, so mainly the questions that we are going to get are from two topics in sets. The first one is the representation of a set, and the second one is about the subsets. Okay, the number of subsets and the overall subset concept. Okay, so without any further delay, let us take up the first question. The first question says the set builder form of, okay, I think there's a typing mistake here. The set builder form of the set A equal to -1 comma +1 is, okay. So if I take up the first one, the set of all x such that x is an integer, if I take this, it is going to be what? X can be any integer, right? So therefore it is going to be 0, 1, 2, and so on towards this side, and -1, -2, and so on towards this side. So obviously it is not option A, right? So it is not option A. I will just strike it off. And coming to the second one, x set of all x such that x is the root of the equation. So therefore, if I take this to be the root of the equation, x square plus 1 equal to 0. So x square will be equal to -1. So x equal to plus or minus root of -1. What is root of -1? It is plus or minus I. So therefore, it is going to include plus I and minus I, not plus 1 and -1. So therefore, option B is also wrong, right? So coming to the third one, x is the set of all real numbers. So again, it is not correct. And of course, fourth one must be right, right? But we'll just see if it is right. X is the root of the equation x square equal to x square equal to 1. So x square equal to 1. This implies x equal to plus or minus root 1, which is 1. So therefore, it is plus or minus 1. Therefore, it is going to include plus 1 and -1 both. So uh, option D is going to be the correct answer. So this is the correct set builder for of the set A. Okay, coming to question number 2. This was asked in 2014, as you can see here. It says the set A equal to the set of all x such that modulus of 2x plus 3 less than 7 is equal to the set. Okay, so here you come across two concepts. One is the modulus function and the other one is the linear inequalities. So uh, you have done those in theory, but we have not yet revised those concepts in this particular crash course. But still, assuming that you know the least possible basics, I shall take up this problem. So it says A equal to the set of all x such that mod of 2x plus 3 is less than 7, right? So I have to write down all those x which will satisfy this inequality. Okay, so one property of modulus, as all of you may know, that if mod x is less than a for any positive a, then I can write down x greater than minus a and less than a. Okay, so therefore here for this inequality I can write down 2x plus 3 is less than 7 and is greater than -7. Okay, so by the properties of linear inequalities, I will subtract 3 on all the sides. So I'll get -7 minus 3 less than 2x less than 7 minus 3, which is going to give me -10 less than 2x. Okay, and then less than 7 minus 3 is going to be 4. So if I divide this on all sides by 2, I'll get -5 less than x less than 2. So this is what I'm going to get. But as you can see, none of these are matching here. None of these are matching, right? So see, but I can still rule out a few. it says x is greater than minus 5 and less than 2. So here it says x is greater than minus 3. So this is obviously wrong, and this is also obviously wrong. And the option D says 2x is greater than minus 13, but here I have 2x is greater than minus 10. So therefore option D is also wrong. So the only option that I'm left with is option A. Now we'll see if it is correct. What does option A says? It is x plus 5 has to be in the middle. So what I'll do is I'll add 5 on all the sides. So I'll get minus 5 plus 5 less than x plus 5, okay, less than 2 plus 5. So minus 5 plus 5 is 0, less than x plus 5, less than 2 plus 5 is 7. So obviously it is going to be the correct answer, because x plus 5 is greater than 0 and is less than 7. That is what exactly we have got. So it is going to be option A. Okay. So these are pretty simple problems that they have given. Okay. So again in 2023 there was one problem that was asked on an empty set. Of course, again it is going to be an easy question. Which of the following is an empty set? What is an empty set? Empty set is the set which has no elements, absolutely. Okay. So if I take up the first one, option A, what is it? The set of all x such that x square minus 9 is equal to 0. So x square minus 9 equal to 0 means x square is equal to 9. This implies x equal to plus or minus root 9, that is 3. So this is going to be plus 3 comma minus 3. So it is not an empty set, of course. So option A is wrong, right? I'll just mark this out. Option A is wrong. Coming to this one, option B, what is it going to be? It is x square minus 1 is equal to 0 implies x square is equal to 1, which will give you x equal to plus or minus 1 by taking the root. So this is equal to 1 comma minus 1. So it is also not an empty set. Gone. Okay. Coming to the option C, it says x square is equal to x plus 2. Okay. So this will give you or else what I can do is just simply you can solve this. X square minus x minus 2 is equal to 0. You'll get a quadratic equation, but it is very obvious here. If I put 2, it is going to be 2 square, which is 4, and if I put 2 here, it is 2 plus 2, which is 4. So it is going to get balanced. So x equal to 2 is one of the solutions no matter what. So this set will contain 2 no matter whether it contains another element or not, because see, it is a quadratic equation. So quadratic equation can have maximum of 2 roots. So one of the roots is 2. By just by looking at it we can make out. So therefore since it is containing one element, it can never ever be empty. So I can just strike off this option also. uh, Coming to the option D, it says x square plus 1 equal to 0. So this will give me x square is equal to minus 1, which in turn will give me x equal to plus or minus root of minus 1, which is plus or minus I. So you might obviously say that it is plus I comma minus I, but I is not a real number. It says x is a real number. So these two will never appear here. So it is going to be an empty set. Okay, so the answer is going to be option D. So if I remove this x belongs to R here, so none of these are the empty sets. Okay, all of these are, none of these are the empty sets basically. Okay, all of these are going to have two elements. Uh, since they have mentioned x is a real number, I can say that option D is the right answer. Okay, coming to the question number 4. What does the question number 4 says? If A and B are finite sets and A is a subset of B. What do you mean by A is a subset of B? What do you mean by A is a subset of B? All the elements of A are in B. Okay. So then the options, if you look at the options, it says n of A union B equal to n of B, n of A intersection B equal to n of B, n of A intersection B equal to 0, and n of A union B equal to n of A. Fine. What do you mean by n of A? It is the number of elements in the set A. Okay. So if I take, let's say, a set A equal to 1, 2, 3, so on up to 10, then I can say that n of A is equal to 10. Okay. So that's all. Anyways, we have studied this in the previous lecture, so I'll not repeat it again. Let's continue with the problem. So, see here it is given that A is a subset of B. That means all the elements of A are in B. So, if I take, let's say, since all the options are in terms of union and intersection, if I take A union B, what is going to happen? See, A is a subset of B. So, all the elements of A are in B. What is A union B? It is A or B. Okay, so we are basically going to list down the set of all elements which are either in A or in B or in both. Okay, but anyways the set of, I mean the elements of A are in B, already in B. So therefore, if I list down the elements, I'm basically going to list down the elements which are in B. I mean, I'm basically going to list down the entire set B. So it is going to be B. If you are not getting what I'm saying, I'll just take an example. This is a bigger set. I'll take it. Let's say A is equal to 1, 2, 3, and let's say B is equal to 1, 2, 3, 4, 5. So what is going to be A union B? A union B is going to be the set of all elements which are either in A or in B or in both. 1 is in both, so I'll include it. 2 is in both, I'll include it. 3 is in both, I'll include it. 4 is only in B, still I include it because either in A or in B, right? So that is 5 is also in B, I'll include it. So it is going to be B. So I can make out a property here. If A is a subset of B, then I can say that A union B is equal to B, right? Similarly, if I take A intersection B, what is it going to be? It is going to be only the common elements, right? Since all the elements of A are in B, it should be A because these elements will be common in both A and B. So it is going to be A. If you list down, it is 1, 2, 3. So which is the set A. So I can also say that if A is a subset of B, then A intersection B is going to be A, right? So therefore, A intersection B is going to be A. This is what I have. So A union B equal to B and A intersection B equal to A. So if I look at this, since A union B and B are the same sets, I can say that the number of elements in A union B is equal to the number of elements in B. And I can also say that the number of elements in A intersection B is equal to the number of elements in A. Okay, so I'll try to match the options now. The number of elements in A union B is equal to the number of elements in B. So it seems to be true. Not seems to be true, it has to be true. So option A is right, but I'll also check with the other options. N of A intersection B is equal to N of B, which is wrong. N of A intersection B is equal to N of A, so therefore it is wrong, right? And N of A intersection B is a null set. No, A is a subset of B, so therefore there has to be at least one element belonging there. So absolutely no. Next is and by the way, this is a very no, it's correct, fine. And the next one is N of A union B is equal to N of A. Of course no, it is N of B, so therefore this is also wrong. So certainly it must be the option A. Okay, coming to the next question, that is the fifth question. If A is equal to the set 1, 2, 3, 4, 5, 6, then the number of subsets of A which contain at least two elements. Okay, so what do you mean by at least two elements? So when I say at least, it resembles the word minimum here. What do you mean by minimum? I need minimum to minimum two elements. So that means if I have to make the subsets of these, I mean this particular set, see, if I am making the subsets of this, I can have an empty set which has zero elements. I can have singleton sets, I mean six singletons, let's say singleton set 1, 2, 3, 4, 5, 6. So it is, I'll have six sets, and then I can have two elements which are the subsets, let's say 1 comma 2, or let's say 1 comma 3 or 2 comma 5, anything like this. So I can have so many subsets, and then I can have three elements, I can have four elements, I can have five elements and six elements. But what they are saying is they don't want this null set which has no elements and the singleton set which has one element. They need at least two elements. I mean, they need at least two elements in the subset. So I have to basically count this. So what I will do is, see, basically what I have is I have the subsets with zero elements, one element, two element, 3 elements, 4 elements, 5 elements, 6 elements. Yes, that's all. So I don't want these two. I mean, I need minimum of 2 elements. So 2, 3, 4, 5, 6. So first what I will do is I will calculate the total number of subsets. Okay. And then I will calculate the number of subsets which have 0 elements. And then I will calculate the total number of subsets which have 1 element. And then I will subtract those two out of the total. Then I'm going to get the exact number of subsets that I need. Okay, so what I'll write down is the number of subsets of A with at least two elements. Two elements. Okay, this is equal to total number of subsets. Total number of subsets. Okay, of A minus number of null subsets. Okay, and see the number of subsets which have 0 elements minus the number of singleton subsets. Singleton subsets. So this is what I have to do. Okay, so this is equal to, what is the total number of subsets? I had said yesterday, if a set has n elements, then the total number of subsets are going to be 2 raised to n. So it has how many elements here? 6 elements. So the total number of subsets are going to be 2 raised to 6 minus that number of null subsets. There will be only one null subset, which is an empty set. I mean, it's obvious, right? So one null subset minus the number of singleton subsets. What are the singleton subsets here? It is singleton 1, singleton 2, singleton 3, so on up to singleton 6. So these are the 6 subsets that I have which have only one element. So minus 6. So it is 2 raised to 6 is how much? It's 64 minus 7, which is going to be 57. So therefore option B is certainly obvious. Okay, so this is how you can do it. Now coming to the question number 6, it is again on the subsets. As you can see, there are too many questions which have appeared in the previous years on subsets. So it is better to solve more problems on the concept of subsets, the calculating the number of subsets, etc., which is of good use. Okay, so fine, we'll take up the 6th question. What does it say? If A equal to 1, 2, 3, so on up to 10, then the number of subsets of A containing only odd numbers is. Okay, so see, if I note down the elements of, I mean the subsets of A, it can be the singleton 1, or let's say it can be 1, 2, or let's say 2, 5, or 2, 5, 6, anything like this. Okay, so it can contain any of these elements. But what they want is they want the subsets of A which are containing only odd numbers. So what I can do is I can consider only the odd numbers of this and then make a subset. I think that would be better. So if I consider only the odd numbers of this, it is going to be 1, 3, 5, 7, 9. So it would be better if I make the subsets out of this, right? So how many number of subsets that I'll get out of these numbers? It is going to be 1, 2, 3, 4, 5. So it has 5 elements, so it is 2 raised to 5, which is 32 subsets. These 32 subsets will have only and only what? Only and only the odd numbers. Okay, and if they ask in case only and only even numbers, how will you do it? Only even numbers are going to be, it is 2, 4, 6, 8, 10. So therefore it is going to be 2 raised to 5 again, so 32. So therefore this is what you have. 32 subsets will have only odd numbers, 32 subsets will have only even numbers. Total number of subsets are going to be how many? It is going to be 2 raised to 10, because there are 10 elements. So out of 1024 subsets, there are 32 subsets which have only odd numbers, 32 subsets which have only even numbers, and the remaining subsets, that is 1024 minus 64. I am not very good at calculations. 1024 minus 64, you do it. these many number of subsets are going to have the mixture of odd and even numbers. Okay, there can be a question like this also. Uh, then the number of subsets of A uh, containing both odd and even numbers. So not only odd, not only even, then it is going to be 1024 minus 64. So for this question, for time being, the answer is going to be option C, that is 32, obviously. Okay, so let's come to, I think, yes, I think the last question. The seventh question. What does it say? Two finite sets have m and n elements respectively. Okay. Uh, the total number of subsets of the first set is 56 more than the total number of subsets of the second set. Then the values of m and n respectively are. Okay. So let us say I have two sets. They are saying there are two finite sets having m and n elements respectively. So I'll take two sets A and B. Let us say A has m elements and B has n elements. So total number of subsets are going to be 2 raised to m for A, and total number of subsets are going to be 2 raised to n for B, right? So what does it say? The total number of subsets of first set, okay, the total number of subsets of first set is 56 more than that of the second set. So which is lesser here? 2 raised to n is lesser because this is 56 more than this. So if I add 56 to this, then I'm going to get 2 raised to n. I hope what I'm talking is making sense here, right? So which is larger? 2 raised to m is larger, which is lesser? 2 raised to n is lesser, right? So 2 raised to m is equal to 2 raised to n plus 56. So let us just cross check whether it matches the statement or not. Yes, it does. The total number of subsets of the first set is 56 more than that of the second set. So then the values of m and n are respectively. So here I have 2 raised to m equal to 2 raised to n plus 56. We'll just substitute and see whichever matches, that is going to be the answer. So if I put option A, m equal to 7 and n equal to 6, what am I going to get? 2 raised to 7, and this side I'm going to get 2 raised to 6 plus 56, right? So what is this? 2 raised to 7 is, I think, 128. 2 raised to 6 is 64 plus 56. So it is going to be 128. This 6 plus this is going to be 0. So these two are not equal. In the unit place, 6 plus 4, it is going to be 0. So option A is wrong. Right. Option A is wrong. Next, coming to option B. What does option B say? M equal to 5 and n equal to 1. Let's see. 2 raised to m is 5 and 2 raised to n is 2 raised to 1 plus 56. What is 2 raised to 5? It is 32. Here it is already 56, so these two are not equal, of course. Next is what? Option C. Option C says 6, 3. M equal to 6 and then n equal to 3. If I substitute 2 raised to 6, 2 raised to 3 plus 56, it is 2 raised to 6. 2 raised to 6 is 64. 2 raised to 3 is 8 plus 56. So it is going to be equal, right? So 64 is equal to 64. So it must be option C. So option B is wrong. Option C is right. And of course, 8 and 7 may not match again. So it is not correct. You can just substitute and cross it. Okay. So these are the few problems that I got from the previous year question bank or the previous year KCET question papers. What you can do is you solve a few more problems from the representation of set and the number of subsets, and then the union and intersection of sets and the operations on sets. In the next lecture, what we shall do is we shall take up the chapter relations and functions. If necessary, we will revise it, and then we will take up a few more problems on the relations and functions also. Okay.